You've just purchased an iX7 Servo from Automation Direct and want to get it set up and running? Before we begin, a quick reminder. Safety first. Make sure all power is off, that you're a qualified installer, and that you follow all local codes and standards. Servos are amazing, but only when respected. Keep the motor uncoupled from the shaft during initial startup and testing as well. Our system will be based on the 200-watt iX7 servo motor without a brake. It will drive an LAHP linear actuator and will be controlled by the 400-watt iX7 servo drive. The drive will be connected to an XMC motion controller for EtherCAT control. We have positive and negative overtravel sensors on the actuator assembly, as well as a home sensor. These will be direct wired to the servo drive. Additionally, we have a 3-position selector switch, red and blue indicator lights, and a green illuminated push button. This I/O will be controlled by the XMC motion controller. The system also includes all necessary circuit protection, a 24-volt DC power supply for powering the motion controller, and a second for I/O power. Let's start by mounting the servo drive. It mounts directly onto a control panel. For proper cooling and accessibility, give it at least 10 millimeters of clearance on each side and 100 millimeters above and below. There's no specific front clearance requirement, but make sure you have room for cables and wiring and can see the drive display for status information. Next is the XMC motion controller. This unit snaps onto a 35mm DIN rail. Pull down the bottom locking hook, set the top hook onto the top edge of the DIN rail, then rotate the unit down until it clicks. Push the bottom hook back up, securing the controller. Give it 50mm of clearance on each side, 30mm above and below, and 100mm in the front. For main drive power, all iX7 models accept single or 3-phase 230-volt AC. The 400-watt model can also use single-phase 110-volt AC by setting bit 15 of parameter 0x2034 to a 1, which is a decimal value of 32768. A 110-volt AC is what we're using today. For single-phase wiring, you can use any 2 of the 3 power terminals, so we're connecting to L1 and L2 through a 15-amp circuit breaker. Control power connects at C1 and C2, and we'll run that through a 5-amp breaker. Make sure the PE earth-ground connection is secure. Servo systems absolutely depend on solid grounding, even during initial testing. For motor wiring, connect the phases to U, V, and W, and connect the motor ground to the PE terminal at the bottom of the connector. Everything is color-coded and labeled, so pay close attention. Reversing a phase will cause an unrecoverable error until the phase is correctly connected. Connect the encoder to CN2. If your motor has a brake, wire it to either your external brake control method or to the drive's digital output assigned for braking. This is set to DO1 by default. We strongly recommend you wire a constant 24-volt DC to the brake during initial startup and testing to avoid any mistakes or damage. For STO wiring, use the CN6 terminal. You can connect to a safety device using the APCS STO cable. While the included bypass dongle exists, it's strongly recommended to use a proper safety relay or device. This gives you a reliable way to remove torque if the motor runs away. We'll be using a doled safety relay wired to an emergency stop push button. We'll also run the STO connections through terminal blocks so we don't have to strip back the factory cable sheath. For drive I/O, connect the breakout board and cable to CN1. We'll wait to wire the breakout board until after the motion controller is hooked up. Power for the XMC controller can be 24-volt DC or 110 to 240-volt AC, depending on the model. Ours is a 24-volt DC model, so we'll power it from our controller power supply and connect the controller ground. For communications, connect an Ethernet cable from the controller's EtherCAT port to the drive's EtherCAT in port. It will not work if you connect the controller to the drive's EtherCAT out port. Connect another Ethernet cable from the programming computer to the controller's Ethernet port. And finally, connect a USB cable from the computer to the drive, so we can configure the drive and program the controller at the same time. Now it's time to wire our I/O. For the drive, we're using 3-wire NPN-style home and overtravel sensors. Using terminal blocks allows us to avoid stripping back the sensor jacket. We'll supply 24-volt DC to each sensor's positive wire and 24-volt common to each sensor's common wire. We'll also bring 24-volt DC from the I/O supply to the drive's plus 24-volt terminal. We can then land the output wire of each sensor to the digital input terminal on the drive. DI1 is our positive overtravel, DI2 is our negative overtravel, and Di3 is our home sensor. For the XMC controller, digital inputs can be wired as either syncing or sourcing. In this design, we're using syncing inputs. The I/O supply's 0-volt common is connected to the controller's digital input common. Di1 is wired from plus 24 volt through the left selector switch contact to the Di1 terminal. Di2 is wired from plus 24 volt through the right selector switch contact to the Di2 terminal. Di3 is wired from plus 24 volt through the green push button contact to the Di3 terminal. The XMC digital outputs are syncing outputs. The 24-volt I/O supply is connected to the positive side of all three indicator lights and to the controller's output module positive terminal. The red indicator is connected to the DO1 terminal, the blue indicator is connected to the DO2 terminal, and the green push button indicator is connected to the DO3 terminal. The controller's 0-volt common is also tied to the I/O power supply common. Once wiring is complete, we'll turn on the main circuit breaker and check AC input voltage, plus both power supply outputs. Everything looks good. Next, we kick on controller power, and the XMC comes alive. Bringing up the I/O breaker doesn't trip anything, and finally the drive's AC power and controls come up. And the drive powers up without issue. No breaker trips, no mystery smoke. Perfect. For further details, please refer to the Quick Start Guide available at AutomationDirect.com. It condenses key information from the LS manual into an easy-to-use format, while the full manual remains the best resource for detailed technical reference. Congratulations! Your hardware installation is complete. You're officially ready to move on to configuration and commissioning, and it didn't take long or cause any headaches. Just another reason Automation Direct is the #1 value in automation. If you have further questions, please contact our free, award-winning technical support team. For more videos on LS Electric EtherCAT servos, click here. To browse our iX7 offering at AutomationDirect.com, click here. To subscribe to our YouTube channel, click here.